Okay, so we get only 1 month and 2 more weeks will be end for the fall. Okay, so summer only short, only 2 months. And I believe fall, you guys will be get back to the lab. And the end of this month, we will be get the final for electronic. That will be 50 questions. And 40 questions will be inside whichever quiz I already gave it to you. I just adding 10 more, a little new. That will be given to you. If you're working okay, you can get B. If you get a better, then you're able to get an A. Okay? So you want later on, you don't have to take any more electronic. Then try to pass through it. Okay? If you're not, that means you still owe me. You
Hey,
have
Mr. Pham.
to do that. Yeah.
So basically all you're saying is for the final, make sure you study all the quizzes because 80% is going to come from all those quizzes.
Exactly.
Okay.
Only thing I just want you to learn it and get the knowledge to be a technician. Okay? Any question? Anything? Is it too much work or what?
Good
You
job,
gave
Mr.
me
Pham.
you gave me more knowledge than I was expecting.
Yeah, I have a question about the format of the final. Is it going to be a timed exam online, or how is that going to work?
Still the same like the quiz.
Thank you.
Do it today and turn it in next day?
Yeah. But only next day to get the C.
Only next day, not a week, right, Mr. Pham?
No.
You gotta move on.
So if we do it today at 12, we got to turn it in before 12 the next day.
The thing is, you guys to be a technician. Not asking you too much detail. Okay? You just try to test the circuitry. And I have to spend more time to teach you how to do your job when you get the knowledge. Okay? For example, when you do the left phone, first thing you run it, they're telling you to connect the circuitry like the way they want it. Then they say, you apply the sideways, whatever frequency, whatever volt, peak to peak, then you measure the output. Now, when you get fail, what you think you can do? The thing is, the left one, you have to get the right answer. They allow you to move to the next one. Otherwise, you stop up there. So in the case, you follow the instruction and you do it, and it's not working. Then what can you do? Who can tell me what you think you can do?
Keep studying.
Now, you're on the lab. You have to solve the problem. You let you study. I try to repeat it, make sure you are following me. You run the left one, they show you build this circuit. That means you have to using the 2 pole to connect to make sure your circuitry is right. Then they say, okay, apply sideways, volt peak to peak frequency. Okay, then using the scope, measure the output, now you get a drop. Incorrect. What do you think you can do? You understand the electronic is not lucky.
Check
Okay.
your circuit.
Then, okay, one to say, check the circuitry. Okay, I agree. You make sure you connect right to your circuit. Okay, after that, you say, okay, look like circuitry, okay. What next?
Make sure the input is correct.
How?
Check power and ground.
No, he said make sure the input is correct. I've given you example. You want one volt peak, okay? 1 kilohertz. How come you check your input is correct? Tell me.
Use the oscilloscope.
Use DM.
Come on,
Oscilloscope.
come
I
on.
can I can check the output from the signal generator using the oscilloscope, Mr. Fan.
No,
Why not?
no. You already set up everything. They want 1 volt peak to peak, 1 kilohertz sideways. That means you follow it and you do it, right?
Yeah.
Then you measure the output. I say the output incorrect. I asking you, okay, what you want to do? And the first student say, okay, check the circuitry. I agree. You looking into your circuitry and looking into the display of the circuit they wanted. Make sure you connect the right pole to connect the circuitry. That's okay. Now you see nothing wrong with the circuitry. What next?
Make sure what you have coming out of the function generator is what you have going into the input of the circuit.
So, okay, now you have to telling me. You say, make sure you get a right input, right?
Yes, coming out of the function generator to the input of the circuit.
Hold on. You say you want to make sure you get a right input.
Correct.
Okay. Then the question is how? How you can make sure you get a right input?
You
Using
gotta-
the
gotta-
oscilloscope to check that that is the right input to the circuit.
Okay.
No, I think what he's meaning is that on the function generator, there's some connections there that you have to check, go directly to make sure, because just because it says it on the screen, maybe there's something that's changing the reading, but it's not what should be read coming out. I don't know if I'm saying that right.
Okay, now.
How about just follow the procedures? If you miss the procedures, you go back a step. Those procedures don't clarify, and you keep going back to the beginning, clarify the process. The first steps, go to the second step because it's lab volt. Lab volt is particular to the PDF that we've been studying based off of what the instructors are showing us. So lab volt is sensitive to the instructions. So you have to follow the instruction.
Now, what I'm saying is, you follow the instruction to do your lab. Connect generator, set up the voltage, okay, and using the scope to measure the output. And now I said you get the incorrect. That means something must be not right. Then you say, okay, first thing, I have to look into the circuitry, make sure wiring okay. Now, I said, okay, you done good job, check wiring. Nothing wrong. What next? You say, you check the input, make sure it's right. Okay, I asking you how. Only thing you can telling me, you connect the scope to the input and you look on the scope to verify. You get the 1 volt peak to peak sideways and 1 kilohertz. That means your input is correct. Now,
Mr.
yeah, go ahead.
Just trying to say that we're trying to say that a few minutes ago and you say no. I don't understand what are you expecting for an answer here?
No. That's what I try to make sure you can follow it. I say,
Hey,
check
Mr.
the input. Okay,
Hey, Mr. Pham,
yeah,
the way I was understanding this is, even though you build a circuit or whatever, you're going to have something going into the circuit. And I don't want to get onto digital, but I know you always say you got the right input, but the wrong output. So we go back to the input and see if we got the right input going in. To do that, we get a signal out of the signal generator. We
Yeah.
need to make sure, that the signal coming out of the signal generator is what we actually want.
right. I understand, but what I'm saying is, you said the circuitry wiring good, and I said you check the input signal, make sure you get what you want, right?
Correct. Go ahead.
You just telling me using the scope connect to the input and verify on the oscilloscope to make sure you get a 1 kilohertz.
Yeah, but the input of the generator
No.
first.
I just not done.
Okay, go ahead.
I telling you to take the input, then now you say, okay, I connect the scope, go to channel 1, and I verify on the display. Should be 1 volt, peak to peak 1 kilohertz. Okay?
Okay.
Now, next question is, you get the right input or not? Then you have to telling me. If you get the right input, what next you want to do? If you not get the right input, what you want to do?
Check your oscilloscope and make sure you have your source input selected correctly.
Okay, now.
Or checking the power supply?
No, come on. We don't do anything with power supply right now. You measure the input signal, and I want the 1 kilohertz sideways.
Right.
Play on the scope, and now you say you not get that sideways, or 1 volt peak to peak, or 1 kilohertz. Then, what next you want to do?
Check the parameters in the signal generator if you are not getting the right signal.
Now, you're talking about general. I want you to tell me what to do.
Change the generator.
Change the cable.
Okay, and I telling you what to do. The thing is that will be helping you to deal with the problem. Okay, first thing, I not connect generator into the circuitry. I connect directly a generator to the scope channel 1. 1 or 2 doesn't matter to me.
That's what I was saying in a roundabout way.
Do not deal with the circuitry right now.
Correct.
You connect the generator output to the scope. They're supposed to be displayed.
Right.
Okay, the signal correctly. Okay, now 2 things. If you get the correct signal, or you not get the correct signal, first thing I say, you cannot get the correct signal. What you want to do?
Check the probes.
Okay, you can take the probe. That's the one. What else?
Change the generator.
No, not easy. Not change generator yet. You can take the probe, okay? Make sure you know how to connect the right way, okay? And also make sure you know how to work with your oscilloscope.
Okay, check the coupling, AC coupling.
No, not yet. The thing is AC coupling or DC coupling doesn't matter. Right now you get a sideways, they still display sideways.
Hey, Mr. Pham, what you're trying to get us to say is there's something in the hardware that's going from the generator to the scope that we need to be checking, correct?
Okay, you say you display correctly from generator to the scope and the signal not working.
Correct.
Okay, so either the scope get a problem
Or the coaxial cable.
or the cable get a problem or the generator get a problem. And you can try, but look like it not work out. What night?
Call Mr. Pham.
Right, exactly. You understand that when you're working in the lab, we get 2 rooms, 240 and 250. Each room we get a 1 lab instructor. Try to help you guys out. Another one will be Sam, that assistant also will be help you. So in this case, don't do anything. You cannot change your generator. You cannot change the scope. Then you have to raise your hand. When they come, they will be help you out. Okay? The thing is normally you understand the cable connect to the generator. They not allow you to remove that out. So don't try to change another cable. The thing is instructor or Sam can be changed. In the past, we let the student to change it. A lot of students don't know how to do that damage to the generator, and we have to fix that problem, okay? So now that is how to solve it. The signal coming out of generator is not okay. So now if you connect the generator into the scope and now display sideways very good. So when you connect again back into your input of the circuitry, okay, and when you measure the output, they still incorrect. What can we do?
After the instructor's been asked to come and look at the equipment?
You mean the scope generator not working?
Right. We've made sure you've come over and you looked at the equipment. So if we've already done that, then we're expecting the equipment to be working, and then we can go ahead and follow with our project.
Okay. Now I'm talking about generator and the scope, no problem. Okay. Then you connect it back to your circuitry. And they still incorrect. Okay, normally for the engineer or technician, you know how to do. You don't have to follow in exactly the instruction from the left volt. For example, they say connect channel 1 scope to input, connect channel 2 to the output. Okay, and I measure the output. To me, I don't care. I using only 1 channel, that's okay. Only thing is they want me to measure the output, then I move the scope channel 1 to the output. You see that? Only thing I want the measurement. Now, when you're using a channel 2 to measure the output and you get a wrong answer, what can you do?
Use channel 1 to measure and double check. If that still doesn't work, then call the instructor to get the check the board, because the board probably is faulty.
But we're using 2 channels, correct?
No. You don't now I'm talking about you using two channel. Okay. Right
Just
now.
just make sure that on the oscilloscope, source 2 is selected to make sure that you get the correct values.
But you not get the correct values.
I think we should
And
at least
if
try
it,
what,
no, if the oscilloscope's still working, if you don't get the correct values and you have your oscilloscope set up correctly and you're on source 2 and your cable's working, you're at
Okay, now,
times 10 or times 1. The only thing is your component has an issue.
now,
hey, what I was gonna say is, why don't, like, you do what Michael said, okay, everything happened according to the way Mr. Pham said it happened, but you hook up channel 1 and channel 2 a certain way, and it doesn't work, then like Mike was saying, switch things around. Whatever was on channel 2, put it on channel 1, and whatever was on channel 1, put it on channel 2, to make sure both channels on the scope is working.
Which is true. Most you would expect that the channel 1 and channel 2 to work as soon as the instructor walks away. So, but that's not going to be the issue though.
okay, now, I'm talking about using two channel. Okay, you already guarantee channel 1, okay, working perfect. When you using channel 2, you measure, you get a wrong answer. Then maybe the circuitry not working. Or maybe channel 2 to your scope is not working. How can we check your scope channel 2 is working? That tries to isolate the problem.
Yeah, but that's what we were saying, Mr. Pham.
Yeah,
Take
exactly.
take channel 1 stuff and put it on channel 2, and channel 2 stuff, put it on channel 1 and see if it's working.
But that's
Oh, yeah.
but that's the problem. And just recalling what Mr. Pham said, when the students go into the lab, it's not their responsibility to fix anything. And that doesn't mean you start removing cables.
No,
And
no, no,
start
no,
trying to-
no.
No, but
I'm not,
that's what's happened, Joe, is students want to start changing out cables
no, no, no.
to
Well,
fix it
I'm not,
themselves. You know,
I'm not saying change out cables. I'm just saying, okay, you got the lead that hooks onto a part of the circuit. You take that lead, say, and put it on the one that was on channel 1, and take the lead that was on channel 1 and put it on channel 2. Just
That's
swap
what-
them around. I'm not saying disconnect anything.
Okay. Okay.
but that's what I'm saying. You're not supposed to touch the equipment.
Okay, hold on. I'm telling you. Right now, I'm talking about you measure the output with the channel 2, you cannot get the answer you wanted.
Right.
Maybe you think, that's what I'm saying. Your channel 2 is not working right. Or your circuitry not working right. Now I'm talking about first thing.
Use
One by
channel
one, okay? If you want to make sure channel 2 working okay, what can you do? I'm not telling you unplug that, connect to channel 2. No, you don't remove. However, now I'm telling you, just get the scope channel 2, connect to channel 1. Make sure you get exactly the same signal. You see that? They're telling you no problem with the channel 2.
I think what Mr. Pham is saying is that you have to measure the input with channel 1 and with channel 2. And if you don't get the same answer, then there's something wrong with one of the channels.
With channel 2. Channel 1 we already done.
Yeah.
But that's
Okay.
what we've been resolving is when the instructor walked away, the equipment and the cables were working. But yes, it does make sense, Mr. Pham, that you take channel 2 and just put it on the channel 1 and see if you get the same.
Do not move. Do not move, remove the channel 2. You just unplug, connect to channel 2. Now you connect to channel 1.
That's
Right,
what we're
the
saying.
probe.
That's what we're
Just
saying.
Just a probe, yes.
Yeah,
The
just
probe.
a probe.
The probe.
Okay. Then if they display the same, then you okay. Okay. If they not, that means something with the channel 2. And they not allow you to unplug the cable to get another scope probe. You have to let the instructor know then they will be help you out.
Right.
Right. We got you.
Okay?
Yeah.
Now, for to me, I never using channel 2 or channel 1. Just one channel enough. They want measure channel 1. I make sure I get the right input. Now they want measure channel 2. I measure the channel 2. Only one. Doesn't matter. We want to get the right answer. Only thing when they try to display both signal, then you must be using channel 1 or 2. Okay? Now, next step. You get the right channel. You measure the output, still not incorrect. And you know your equipment perfect. What next you want to do?
Check your circuit.
We already checked the circuit, right?
Well, you would suspect that your jumpers are working correctly.
That's what
Uh,
I already said at the
Right.
beginning.
No, I understand. It's just the reasoning process. We're looking at something visually that all of it is set up based off of what lab bolt instructions are showing, right? So we have all the jumpers, it's all set up.
Right.
But on the output, we're not receiving the channel 2. So as far as what I would do was, regardless if I have a visual correct, this as long as my circuits visually looks correct, I know some of those jumpers sometimes may not be connected to the contact, so you have to check the conductance, right? I know, but that's, you have to
You're
verify that
basically
all
talking
your
about, you're
Actually,
basically talking
ask
about
the,
power and ground.
Ask the instructor and check the board because one of the component might be faulty.
right. But see, you have to make sure that if you're jumping something to a component, that specific jumper is conducting.
Okay.
Sometimes that's the only real issue. But after that, yeah, you have to check the component.
Okay. That at the beginning. I already telling you, check your circuit, right?
Right.
So it's right. Jumper and whatever need to connect to exactly what they wanted. We already take that at the beginning. Okay? So we suppose that have to be done. Then now you get the right input, you cannot get the right output.
And we checked power and ground already.
But if we check all that, that means something got to be wrong with circuit. If we already checked all our cables and everything look okay, like I don't know.
Right,
what was
Now,
that?
component.
normally you can troubleshooting the way you want, measure whatever, whoever. Okay? What I said, yeah. Raise your hand. Instructor will be come. Like, I'm there and you let me know. I come in and I looking into that. And if I know something wrong, I can help you to fix that. However, something else can be happen. First thing, when you plug the circuit board inside the circuitry, inside the system, sometimes you not lock it. So they not good make connection. That's the first. Second thing is something wrong with the component in that circuitry. Okay?
Mr. Pham, you're talking about the lab volt, right?
Right. I'm talking about lab volt only.
Okay, well, then you said something about the locking of the circuit, that the students aren't supposed to do that. You guys are supposed to have already done that.
Yeah, we're supposed to done that. So that will be okay. The thing before the student can do later on, damage to the circuit board or the system, so that we not allow student to remove or insert the board. Okay, so that will be okay. And now only thing is you are not lucky. That means on the circuitry you're working on, one of the component is not working. Okay, so in case I coming in, I say, okay, look like we already done everything. What I need to do, I will be remove that board and get another one and try again. Okay. If they working, then I can make marking on that board. So we have to fix that board. The thing is you cannot fix anything component on that circuit.
Hey,
Those-
Mr. Pham, if I could just say one thing,
Yeah.
in the past, you used to let the students change the circuit boards in the the lab vault, but now you don't allow that anymore. That's what you're saying.
Right.
Okay.
The thing is you understand we get the 18 system up to 20 to run. And each time only one student. Okay. That means you're working by yourself. So following the instruction to do. If you not understand what they're telling you to do, you have to asking the instructor or Sam. They will
Okay.
explain to you.
Okay.
Don't try to do something you don't know. That will be damage to the board. Okay. The thing is, each circuit board cost 1,500. And basically, when they burning, we cannot get a new one right away. That way, lab instructor and me have to working on that to fix it. So next day you can get the board for the student to do it. Okay. So anything you don't know, then just asking the instructor. Okay. For the phone we coming back, you doing a lab up there. Maybe you don't see me. Maybe you can see me up there. However, I still teaching online. Okay.
How are you gonna help us online? Like if we need help, how are you gonna do the Zoom?
Exactly. That's what I'm telling you. Exactly. Okay. So I will be set it up in my house. Okay. The lab exactly what you're doing up there. So when you get a problem, and I also can help you. Okay. You get online and I can telling you what to do to solve the problem. But never try to do and you don't know what really going on. That will be terrible.
You're saying the theory part of the class will probably still be online and only the lab portion will be in the lab.
Yeah, the thing is you understand in the room cannot be allowed to about 50 or 60, 70 students inside one room. No. Still have to keep a distance. So the lecture have to be online. And the lab will be assigned for your guy what time you do, what system you do, what the board you do. Which day in the week.
Mr. Pham, for example, if you have like 10 students in class and maybe like 3 or 4 of those students need help at the same time, how are you gonna do that with Zoom?
No. We get the 2 instructor, lab instructor in each room.
Okay.
Okay,
Alright.
not only myself.
Okay.
Okay, if they can explain it and you still confused, then you can call me on Zoom.
All right.
Okay,
Thank you.
yeah. The thing is that's what I really want to teach. Okay, that means how to deal with the problem. For a while you get along, you can know how to do what to do. Okay, that is your job. However, before we can do it, then you must be get a basic understanding. If you don't know how the diode working, how can I help you? You don't know how the transistor working. Okay, so I can a lot the way we try to do in the program. Now the homework is not much. However, the quiz will be more. I think if we keep going, okay, go over and over and over for the quiz, they will be go to your brain. You see it, you know right away what to do. Okay. That is what we wanted. Any question or any comment or whatever, let me know.
Thank you.
Otherwise, okay. So now I will be go quickly to the JFET amplifier, okay. Revision B. Quickly, so you will be get the time to take the quiz number 18. Okay. Make sure you can download the report for quiz number 18. Okay. Okay, let me share. Okay, so this is a revision B. Now I using normally upload will be not PowerPoint, will be PDF. Okay, that will be have to display at exactly what we wanted. So we already get through this thing here. Only thing is I want to go into the last time we talking about common drain. That's what you will be doing the quiz today. I believe so. If you can understand on whatever I teaching you, that will be easy for the guy to go moving up to the college or to the university. Okay. The thing I'm teaching is not so simple, not so hard, but have to be something you must be thinking. Okay. Okay. That last time we're talking about the source follower or the common drain. When you're looking in the circuitry for amplifier, either bipolar or JFET, then you have to know what the name for that common drain, common source, or common gate. Okay. For the common drain, input will be applied into the gate and output will be from the source. Okay. And the capacitor here for AC they shorted. That means V out or VS will be the same. That's what they get the short follower. That means the output here or the short here will be the same. That's what they get that name. Okay. And this circuitry here we're using the cell bias to build the amplifier. Okay. And also, let's see. Now, this one last time, we already telling you input impedance. That means RG right here. Now, output impedance. That means you're looking from the output here, you suppose the current flowing into it. Then which resistor will be in series? First thing, we don't care about that R small d. This is an internal resistance of the JFET. Okay, so we only count only one resistor RS. That means this resistor, when you're looking here, you can see only RS. Okay, now input resistance okay, but the output resistance is a problem. You get a G out here, you get a RD here. parallel with RS here and parallel with 1 over GM. What is a 1 over GM? Who know what is it? 1 over GM.
V out over GM.
1 over GM. What is it?
Is the resistance of the current GMVGS.
That also this is a resistance. Okay? Resistance from the gate here to the drain here. That resistance, if I believe
Yeah.
I already given you the calculation somewhere. Okay? So we ignore this R small d here. You only deal with GL equal RS parallel with the 1 over GF. Okay, now my question is, if your circuitry here, you get a load, okay? You get an R load right here. So the output resistance will be looking this way. Now, what you think you can get? What here?
RS parallel.
RS. Parallel.
GL equal RS parallel with what?
RL, RS.
Arc load.
This RS here, parallel with what? With what?
RL.
RL, okay. Parallel with which one?
M and
RG.
RL.
1 over,
GM.
GM.
okay, before you can get 1 over GM parallel with S. That's a no load. Now you get a load, then they have to parallel with RL. The way easy to calculation. First thing you calculate RS parallel RL. So easy to calculate it RS times RL divide RS plus RL. Then after you combine, now you will be parallel with 1 over GM. So just using two resistor parallel, more easy to calculation. Instead, you have to using the formula G out equal 1 over GM, 1 over RS, 1 over RL. I don't want this formula. I just using RS parallel RL, then the result will be parallel 1 over GM. Okay, any question on that? That's the one you will be hit into your quiz. Okay, the thing in here, okay, this is a proof. How come you can get 1 over GM? And also in this formula here, okay, okay, in this formula here, I already given you GL equal RS parallel 1 over GM. Okay, so this is in case they want this R small d. But in here, we don't have a given to you the formula with the R load, okay? So make sure you know how to calculate that. And also on this circuitry here, they given to you. That is a cell bias. Normally for cell bias, you want to calculate the DC, you need the graph. However, they only concentrate on the amplify. So that's why they given you already VGSQ and also IDQ. Okay. Then they want GM0. That you know the formula. How to calculate GM0. Okay. 2 times IDSS divide, right? And GM will be GM0 times, okay, 1 minus VGS over VGS of, and they want the input impedance, they want the output impedance, and they want to calculate the gain. Okay, if you get the formula, you're supposed to get it done. Okay, and now on this one here, the circuitry here, common drain. However, they not given you the VGS Q and IDQ. Then also they must given you the graph. And now they not given you the graph, they given you voltage here. If you get a Vs equal 2 volt, that will be easy to calculate the current ID right here. You take 2 volt divide to the RS, you get the IDQ. After you get the IDQ, you're able to get the VGSQ, right? You understand here will be a G, S will be a S, okay? So that will be VGS. And you know a VGS equal VG minus VS. And VG, that's a 0 right here, minus VS. So if you get the VS 2 volt, then VGS will be minus 2 volt. So the key point is they want IDQ and VGSQ. Then the rest calculation will be depending on the formula. Okay? Okay? So on Wednesday, we will be go with the common gate and also the handout for today. They're talking about the comparator. Then after that, I will be trying to help you to review the bipolar transistor for CE amplified, CC amplified, CB amplified, or they will be 2 or 3 amplified connect together. Okay, we'll be go over that review, make sure you guys understand. So you get any question or anything? If I given you too much working, let me know.
Yes, it's too much work.
But the thing I saw, more people doing very good job. You can understand what I'm teaching you here. No problem when you go to the university. You want to be double E or electronic engineering, no big deal. Okay. Any more questions? If it's not, then I think that's a good time for you to take a test. Okay, now make sure you download the record Okay, for this test. Number 18, right? Hopefully I'm not giving you the answer here.
A few would be nice.
Yes, agree.
We're honest students, Mr. Pham. We'll let you know right away.
Share the screen first.
Okay, on the top.
Yes.
Reset the clock.
Because
2 minutes, every 2 minutes. Look like the time is not working. You have about 15 second left. Oh, I guess it is working. All right.
So I try to upload the video tonight, okay? So if you get a chance, you can try. So any question or anything else? If it's not, then we will see you guys on Wednesday.
Good night, Mr. Pham.
That was fun.
Okay.
Yeah.
Good night. Good night, everyone.
Right.
Good night. Good night.